In this lecture, we are going to look into buffers. This is an extension of pH problems we have seen before. Okay. Now, I will reiterate myself about conjugates in this lecture, but first buffer means you would have seen in school the classic definition. Buffer means resist change in pH, but let me rephrase the entire definition just for clarity's sake. Buffers are mixtures of a weak acid and its conjugate base, or a weak base and its conjugate acid. Okay. Generally what they do is they resist change in pH when you add small amount of acid or a base to that system. Okay. Now there are two types of buffer. You have acidic buffer and basic buffer. Acidic buffer is a mixture of a weak acid and its conjugate base. A basic buffer is a mixture of a weak base and its conjugate acid. Okay. How do we write weak acid in general? HA. அதோட கான்ஜுகேட் பேஸ்னா கான்ஜுகேட் அப்படின்னா எப்பவுமே ஒரே ஒரு H plus மட்டும் வித்தியாசம் இருக்கணும். One H plus difference. An acid going into a base means it should have lost a hydrogen atom, H plus. So this is the conjugate base of a weak acid. A base is B. Okay. A conjugate acid means it should have one more hydrogen as H plus. So this is the conjugate acid. So NEET, they have asked very simple questions. They will give you 4 different options. They can ask you which among the following 4 is a buffer or is not a buffer. First thing you want to look at is ignore the strong ones right away. Look at the weak ones. So weak irukkanum, but don't use the term salt. Okay, that's not the right way of doing it. A weak acid and salt and sollakudadu. For example, weak acid, acetic acid and KCl, they are not buffers. Okay, so you need to write it the correct way. It has to be a corresponding salt or conjugate base. It's always correct if it's a conjugate base. For example, if this is acetic acid, to form a buffer I would use its conjugate base, COO minus. Similarly, when I take a base ammonia, I'll use its conjugate acid NH4 plus. These are all buffers. Acetic acid means propionic acid or whatever acid you want. H2S will be HS minus. Okay. I can go one more step and say HS minus is a conjugate base of H2S, but HS minus can still be an acid by itself. Another hydrogen recur. So that's conjugate base of that is H2 minus. H2S and H2 minus are not conjugates. They have to differ only by one H plus. They differ by 2 H plus. Okay. In the example, HS minus, let's put it this way: H2S, HS minus, S2 minus. Okay. So this is behaving as an acid conjugate base, but this HS minus can behave as an acid altogether with this system conjugate base. I can also write this as, if I take this as base, இது base ஆ இது அதோட conjugate acid. நீங்க யாருக்கு conjugate name கொடுக்குறீங்கன்றது முக்கியம் இல்ல. Conjugate just means pairs. Similarly, I can take this as base. இது base. Other conjugate acid is, however you want to name it, they are exactly similar. Okay, so these two forms a pair of conjugates, these two form a pair of conjugates. Okay, similarly these two form a pair of conjugates. I can go one more and say NH2 minus. So this is an acid, this is the conjugate base. I can say idu renduthila compare panna idukku da hydrogen adhigama irukku. Sorry, this is base conjugate acid. This compare panna idukku da hydrogen adhigama irukku. So this is an acid, the corresponding conjugate base. Okay, or I can say this is the base, this is the corresponding conjugate acid, or I can say this is the acid corresponding conjugate base. This acid na this base, yara orutharukku conjugate endra tag neenga podanum. So this is the fundamental of a buffer. You need to have a mixture of these two to have a buffer. Why buffer resists change in pH is when you add a small amount of an acid or a base. Let's take an acidic buffer. I add a small amount of an acid. Okay, small amount of the acid will react with the conjugate base and neutralize the effect. I add a small amount of a base, it will react with the acid, neutralize the effect. Similarly, in the mixture acid add pannina base react aidum, base puttingna acid react aidum. Okay, now what will happen to that? If I add a small amount of acid to this mixture, the conjugate base will react and form more weak acid. We will see this separately. Okay, right now I have a basic template of what is a buffer. Okay, I need to have corresponding conjugates. Now next is numerical. Once you figure out what problem is given to you is a buffer problem, it's extremely simple. For an acidic buffer, I'll jump straight to the formula. pH equals pKa of the weak acid. Acidic buffer is weak acid conjugate base, and the weak acid is pKa plus log of conjugate base by weak acid. Okay. When I take a basic buffer, okay, it comprises a weak base and a conjugate acid. Okay. Now weak base and the conjugate acid, because I am dealing with the base, the formula will be POH equals pKb of that weak base plus log of conjugate acid by weak base. Okay. Henderson-Hasselbalch equation, this one extremely useful for you guys. The moment you know that you are dealing with a buffer problem, Henderson-Hasselbalch equation should come to your mind. Okay, the importance of this one is you don't have to have concentrations of conjugate base and weak acid or the conjugate acid and weak base. Moles are perfectly fine. And either moles moles, how do you get concentration? Moles over volume. So this is going to be moles Cb by volume. This is going to be moles Wa by volume. Volume cancels out. Volume cancel out nalladu, because what if the volume is not a round number you don't want to be dealing with. So I can do the entire thing in straightforward when I have moles itself. Okay, that's a key point. Second thing is my pH equals pKa when log Cb by Wa equals 0, right? This implies that this is the case, log Cb by Wa. Log of what is 0? Log of 1 is 0. So that tells me that Cb by Wa equals 1 or conjugate base equals weak acid. Okay. When the concentration or the moles of conjugate base and weak acid are same, pH equals pKa. Okay. This is going to play an important factor later. Same thing I can say here, POH equals pKb when conjugate acid equals weak base. Okay. This comes under a particular condition alone, okay, during a titration problem. Okay. Alright, now let us go into titration and see where this is going to be useful. Now I am going to stick with one type of titration and we can extrapolate from that. Let us say a weak acid strong base titration. Now weak acid is strong base add pandra. CH3COOH plus NaOH gives you CH3COO minus plus Na plus plus water. So this is the acid conjugate base. Okay. All right. Now I have my weak acid in a container. I am going to add my NaOH. So this is going to be volume of NaOH and I am going to plot my pH. Okay. Before I do the first drop, okay, it is just weak acid. So somewhere I have my pH when the volume is 0. Okay. The moment you add one drop, okay, inga NaOH poda acetate form agudhu. Appo the moment you add NaOH, you start forming a mixture of acid and a conjugate base, meaning you are going to form a buffer. So usually the pH will raise and then it will slow off a little, and then this is the profile that you will see for a curve. What you want to remember is ஆரம்பத்தில் pH increase நல்லா ஆகும், கடைசியில் நல்லா ஆகும். இதுதான் equivalence point. Okay, meaning moles acid equals moles base, or I should rather say equivalence of acid equals equivalence of base. At this point we will assume that they are 1:1 ratio. Okay, but look at this segment. The pH is almost constant, or change in pH is almost 0. Okay, what this means is you have a buffer here. Addition of a small amount of an acid or a base, in this case a base, resists the change in pH. So at this point what you can do, to calculate pH, you can calculate x equals square root of Ka times C. The entire place you can use that, but when you have a buffer, it's easier to use Henderson-Hasselbalch equation. Okay, at equivalence point, okay, what do you have is sodium acetate. So at equivalence point, what all do we have? We have sodium acetate plus water. pH is not equal to 7 because it's not a strong acid, strong base. Okay, pH will be greater than 7. Okay, now why would the pH be greater than 7? A lot of people will say that's because NaOH is there, but at equivalence point I have not a single molecule of NaOH, it's completely used up. Okay, the pH is greater than 7 because acetate is there. So this is where the concept of conjugate is important. How much ever an acid is weak, its conjugate is a strong base. Okay, strong base is, let's put it this way, acetic acid. Acetic acid எவ்வளவுக்கு எவ்வளவு acidity வீக்கா இருக்கோ அவ்வளவுக்கு எவ்வளவு acetate-ன்றது basicity ஸ்ட்ராங்கா இருக்கும். So a conjugate is always going to be stronger. Okay, இது வீக்கா இருந்தா இது ஸ்ட்ராங்கா இருக்கும். அப்போ எனக்கு strong base இருக்கு. strong base இருந்தா pH வந்து greater than 7 ஆ இருக்கும். When I say strong base, I just mean relatively. இதோட basicity is stronger than the acidity of this one. So stronger base னு சொல்லலாம். strong base கிடையாது. NaOH மாதிரி ஸ்ட்ராங்கா இருக்காது. Okay, but still not going to be neutral. Okay, so now any point after this, okay, you have excess NaOH. Okay. How do we calculate pH? இங்கேருந்து ஆரம்பிச்சு இங்கே வரைக்கும் நீங்கள் இந்த ஃபார்முலா யூஸ் பண்ணலாம், இல்லைனா பஃபர்னு கொடுத்தா இந்த ஃபார்முலா ரெண்டுமே சேம் தான். ஓகே, யூ கேன் யூஸ் தட். திஸ் பாயிண்ட் ஐ ஹவ் ஒன்லி சால்ட். யூ ஆர் கோயிங் டு டூ லேட்டர் வி வில் சி. This is a particular point where you are going to do salt hydrolysis formula. Okay. Now, when you have excess NaOH, what this comes down to is, if you go back to the previous lecture of patterns of pH calculation, this is nothing but this whole setup. Acid plus base, this is limiting reagent, this is excess. அப்போ இந்த பாயிண்ட்ல இருந்து என்ன பண்ணுவோம் அப்படின்னா, NaOH excess எவ்வளோன்னு calculate பண்ணுங்க. moles of NaOH excess equals moles of OH minus. moles of OH minus divided by final volume will give you concentration of OH minus. Negative log of that will give you POH. We will do the calculation based on this. Doing a problem is going to help you a lot rather than watching this over and over again. Okay. Alright. This is the basis of what is a buffer. Now the last thing that I want to do, what makes a good buffer? Okay. We know Henderson-Hasselbalch equation, pH equals pKa plus log of conjugate base by weak acid. A good buffer region is basically when pH equals pKa plus or minus 1. So if there is a pKa right there, அதோட plus 1 லேருந்து minus 1, அந்த region தான் buffer நல்லா இருக்கும். Right there, somewhere here, plus 1 to minus 1 pH. Okay, இந்த ரேஞ்சில் மட்டும் தான் buffer. அதுக்கு கீழே போனால் ரெஸ்பான்ஸ் அதிகமாக இருக்குது, மேலே போனாலும் ரெஸ்பான்ஸ் அதிகமாக இருக்குது, பஃபராக இருக்காது. Okay, so this is what is for a acidic buffer. For a basic buffer, POH equals pKb plus or minus 1. This is the buffer region, very good buffer region. Suppose for example I give you a set of 4 different PKBs, 4 different your weak bases. 4 கொடுத்திருக்கேன். உங்களுக்கு ஒரு பஃபர் வேணும். For example your blood buffer. Okay, blood buffer is normally sodium carbonate, sodium bicarbonate, அந்த மாதிரி தான் இருக்கும், அந்த ரேஞ்சில் தான் இருக்கும். Sorry, H2CO3, HCO3 minus, sodium வேண்டாம், general carbonate, bicarbonate and carbonate buffers. Okay, why do you use that is, உங்களுக்கு வேணுன்ற buffer range வந்து 7.3 அப்படின்னா, pH அந்த 7.3 ரேஞ்சில் வேணும் அப்படின்னா, அதுக்கு எடுக்க போகிறதுக்கு pKa வந்து அந்த 7.3 ப்ளஸ் ஆர் மைனஸ் 1ல் இருக்கணும். ஸோ 4 எக்ஸாம்பிள் கொடுத்து எது வேணும்னு கேட்டாங்கன்னா, எதோட pKa வேல்யூ தேவையான pH பக்கத்தில் இருக்குன்னு பாருங்கள், அது POH பக்கத்தில் இருக்குன்னு பாருங்கள். Okay, now one more thing you can do, plus or minus 1, that tells me that log of Cb by Cwa is 1, meaning log 10 is 1. அப்போ Cb by Ca equals plus or minus 1 அப்படின்னா இதோட ரேஷியோ என்னவாக இருக்கும் அப்படின்னா, Cb is to Wa can be 1:10 to 10:1. 1 is to 10 அப்படின்னா log of 1 by 10 is minus 1. 10 is to 1 na plus 1. So in the ratio தான். Similarly, I can say for a basic buffer, conjugate acid weak bases 1 is to 10 to 10 is to 1. In the ratio குள்ள இருக்கணும். Okay? Alright, this is the basis of buffer. I kept it as a separate lecture because buffer by itself, lot of problems come because buffer is the most important thing for MBBS graduates. Okay, human body has buffer, lot of drugs have buffer. So hence I kept it as a separate problem. We'll worry about solving problems altogether differently. Okay, thank you guys.